The main objective of the in-source project is to develop tools to quantify and assess the predicted impact of changes in urban land use due to population growth, climate change, the energy transition, and challenges of providing a truly resilient infrastructure. These tools will be based on a shared urban data model framework integrating 3D visualization tools for stakeholders. The developed tools will be applied in 3 case study regions on different scale: the county of Ludwigsburg in Germany, the city of Vienna in Austria, and New York City in the US.
Due to climate change, cities are getting hotter and wetter.
At the same time, due to global urbanization, they're becoming more crowded.
Mass migration to cities makes for high density, which is efficient, although it places intense stress on existing infrastructure and affordable housing.
As cities develop the means to thrive in this 21st century, urban experts are confronting rapidly evolving challenges that break across silos of expertise.
If we are to achieve meaningful climate progress, urban experts and professionals need to leave their comfort zones and think across disciplines and across sectors. How do you decouple economic prosperity from increased climate impact? How do we grow a population without growing emissions? The district scale is the sweet spot. We can cast the net wide enough to achieve synergies between systems and economies of scale in our interventions, but also avoid the bureaucracy that can intervene at a larger scale.
Here we see the digital twin of Landkreis Ludwigsburg. You see the 3D city model of the entire Landkreis here, the example from Marbach. We can simulate the heating demand of the buildings and show it here. We can simulate the PV potential, so the electricity that can be generated by solar power. And we see land use because we can also use biomass for electricity generation. But of course, we have a conflict here in that sense that if you use the land for biomass for electricity production, of course, you can't use it for agricultural purposes anymore. So with this tool, we can simulate different scenarios and try to find a good trade-off between local food production and local power production.
In the back end, a data model known as Food Water Energy ADE, which is what we are developing in this project. So this Food Water Energy ADE is an extension to CityGML data model, and it consists of all the food, water, and energy nexus parameters.
Case study region, Vienna. Together with stakeholders, we developed case studies for the case study region Vienna in Austria. For example, we perform food, water, energy-related land use change simulations with a developed tool called Food, Water, Energy Land Use Change Simulator. Thus, we want to analyze population and climate change-induced impacts to the food, water, energy system. We further analyzed the human appropriation of net primary production called HANP, a socio-ecological indicator that depicts the appropriation of biomass. This enables to quantify environmental consequences of urban food consumption. Additional embodied HANP analysis will support urban stakeholders for a more sustainable good provision. Visualization tools developed as web applications will allow our stakeholders to engage with the scenario results and increase their dissemination. food, water, energy, land use change modeling and simulation. Based on input from water demand analysis and climate change for different land use categories and population development scenarios, the developed simulator will enable to spatially quantify the changes. Scenario reports presented within a web application will allow stakeholders to engage with the gain system knowledge and collect tailor-made local results. The improved system understanding shall allow decision makers to create sustainable development scenarios, mitigate and adapt to climate change, considering the complex food, water, energy nexus interrelations.
Our case study areas use a semantic city model as an integrated and coherent information hub. This requires an urban data model that integrates energy, food, and water domain in one integrated data model. Another expected result is the stakeholder involvement. The governor's case study in New York is an excellent example of community engagement. The case study regions have been chosen on multiple scale to ensure transferability of the developed methodology in the in-source project. Thanks for your attention. Stay healthy.